I want to talk about how we can use the chain rule in multivariable calculus to do related rates. So, the length, width, and height of a rectangular prism are changing with time. At a certain instant, the dimensions are the length is 2, the width is 3, and the height is 1. At a particular time, L and W are increasing at a rate of 3 meters per second, and H is decreasing at a rate of 1 meter per second. Find the rate at which the volume is changing. Now, using chain rule in multivariable, we start with the idea that our volume is a function of length, width, and height. Length times width times height. So I always like to make a little diagram and say volume is relying on L, W, and H. And those three things are all functions of time. So to figure out, using this chain rule idea, how volume is changing with respect to time, we use this idea that volume is being affected by length and then time. So we say dV with respect to L times dL with respect to time. It's also being affected by width. We follow that branch and we say, okay, volume affected by width and width affected by time. And finally, a function of height, which is a function of time. And we add all those together and it gives us the overall change in the volume. Now, I should just mention, if you haven't watched a video yet on chain rule, you should go back and do that. So, we have three of these things already. We have dL dt. We were told that that was changing at a rate of 3. We have dW dt. We were told that was changing at a rate of 3. And we have dH dt. We were told that was changing at a rate of -1. So we already know the numbers that go in here. But now we need these derivatives. And this represents a partial derivative with respect to L. So if I say, well, let's find the derivative where L is the variable, WH are treated as constants, well, that would just be W times H, and of course we already know dL dt is 3. If we found the derivative of volume where width was our variable, so this is a variable, then our partial would just be L times H, and then 3. And if we found the derivative with respect to H, meaning H is a variable and these are our constant multipliers, we'd have L times W times -1. And now we could simply put in these variables. L is 2, W is 3, and H is 1. So we'd have 3 times 1 times 3 plus 2 times 1 times 3 plus 2 times 3 times -1. So we've got 9 plus 6 minus 6 is 9. So again, a really nice way to do related rates when we can have a bunch of things changing at once. And again, if you haven't watched a video on chain rule yet, you should definitely go back and do that. But essentially, we look at our volume and say what variables are affecting it, and then we say how is time affecting those, and we're able to use this to get an overall rate of change. If this video helped, please like and subscribe for more math help.